Now that we reviewed how to add, subtract, and multiply polynomials, we are going to evaluate functions with polynomials. So we are first going to start with the function f of x is equal to 2x minus 3. I want you to pay close attention to where the x's appear in this statement. F of x appears in the parentheses equals 2x minus 3. When you're evaluating, like for the first example, f of 2, because the 2 is in place of the x, the 2 has to go in place of every other x in the problem. So the first thing I want to do when I'm trying to evaluate f of 2 is look at the original function f of x. F of x is equal to 2 times x minus 3. Notice every time I said the word x, I left an open parenthesis so that I can come back in and replace whatever's in my new problem and evaluate the function at 2, in this case 2. So because 2 is in place of x, every time there's an x, I'm going to put in a 2. So then I'm going to evaluate this. 2 times 2 is 4. 4 minus 3, which is 1. So therefore f of 2 is equal to 1. Now that wasn't really a polynomial, that was just a constant term. So let's go ahead and use that to help us on the next problems. So the next problem is f of a. Notice a is not a number. So because it's not a number, I'm not expecting a number answer. When you plug in a number 2 for the first problem, you get out another number, in this case 1. But when you plug in an a, you're probably going to get something out with a's in it, the variable a. So when you plug in a variable, you'll get something out with that same variable. So go back to the function f of x. Don't write x, leave that open parentheses, equals 2 times x. Because I said x, I'm leaving it open parentheses, minus 3. Now I go back and replace in for x, a. So f of a equals 2 times a minus 3. Well, 2 times a is just 2a. That can't reduce, minus 3, so therefore f of a is equal to 2a minus 3. Notice you plugged in an a and you got something out with a's in it. All right, let's do this again. F of x is equal to 2 times x minus 3. I wrote out my function f, but instead of x's, I'm going to come back in and replace those x's with a plus 1. Okay, once I have that written out, then I have to distribute and combine like terms, which is why we practiced distributing and combining like terms in the previous pages. We have 2a plus 2 minus 3. My like terms are the constants 2 minus 3. So when I add those together, I get negative 1. So therefore, f of a plus 1 is equal to 2a minus 1. All right, let's try this one more time. F of x is equal to 2x minus 3. That's my original problem. But in this case, my new x is negative x. So every time you see an x, you're going to replace the x with negative x. This confuses a lot of students because x and negative x are very, very close. In fact, it's the same variable, but it's something different, so please do it exactly like you've done all the other problems. Notice in all of red, the red colored values is the thing that we plugged into both x's that you'll see appear in the problem. So now I have 2 times negative x. When I multiply those, that gets me negative 2x minus 3, because I'm multiplying the negative 1 times the positive 2. That gets me negative 2. And bring the x, and then that is f of negative x. There's nothing else that's like terms. They don't combine, so we're done. On the next problem, I have f of a plus h. Now this is a little bit interesting because we have two variables, a plus h. But again, it's done the exact same way. F of x is equal to 2x minus 3. Every time I say an x, I'm going to leave that open parentheses. Then I'm going to come back and replace that open parentheses with a plus h, because the a plus h is the item that replaces the x in f of a plus h. Now I'm going to go back and distribute. That gets me 2a plus 2h minus 3. There is no like terms here, so f of a plus h is completely reduced at 2a plus 2h minus 3. Next, we will use a new function, g of x equals x squared plus 3x plus 5. The first problem is g of 2. So when we are looking for the g function, g of x equals x squared plus 3x plus 5. When we have x inside the parentheses, we're going to replace whatever's in the new parentheses with every x that you see in the equation. So when I am looking for g of negative 2, I go back to the g function, which says x squared plus 3x plus 5. And every time that I have an x, I'm going to put an open parentheses so that I can come back later and put in the new value, which in this case is negative 2. So I'm substituting negative 2 in for x. Next, we're going to evaluate, and PEMDAS says we do inside the parentheses, nothing we can do inside the parentheses. Next, exponents. So negative 2 squared means negative 2 times negative 2, which is positive 4. Then going left to right, I'm going to do all the multiplication and division. So that's 3 times negative 2, which is negative 6. And then going left to right, I'm going to do all the addition and subtraction. 4 minus 6 is negative 2. Then keep going. Negative 2 plus 5 is positive 3. So therefore, g of negative 2 is equal to positive 3. All right, let's do the next problem. The next problem says g of a. So I go back to my g of x problem, my function. G of x equals x squared plus 3x plus 5. And every time you see an x, leave an open parentheses. Next, come back and plug in those open parentheses with our new value, whatever's inside the parentheses, which in this case is a. PEMDAS says exponents first, then exponents, and then multiply, divide, add, subtract. But there's not really all that much I can do for this particular problem. I can clean it up by not writing those parentheses. So I could say at g of a equals a squared plus 3a plus 5. Okay, well, what if it's a little bit more difficult than just a? What about g of a plus 3 for the next problem? Again, I go back to my original g function, which is x squared plus 3 times x plus 5. And every time I see an x, I'm replacing it with a plus 3 because that is what's inside my parentheses. Okay, so this one's a little tricky. When you take a binomial and square it, some students want to, and don't write this down, they'll want to take a plus 3 squared and then distribute it that way. That is wrong, wrong, wrong. You cannot do that. Okay? The appropriate way to distribute a plus 3 quantity squared is a plus 3 times itself a plus 3, because that's what squared means, multiply it by itself. Then I distribute, or FOIL, if you like the word FOIL for that. I like to call it double distribute. I take a times a, which is a squared, a times 3, which is 3a, 3 times a, which is 3a, and 3 times 3, which is 9. Distribute on the next one, 3a plus 9 plus 5, and then I'm going to combine like terms. A squared is the only squared term, but I have 3a, 3a, and then another 3a, which gives me 9a. Then I have plus 9, plus 9, plus 5. 9 plus 9 is 18, plus 5 more is 23. So therefore, g of a plus 3 is equal to a squared plus 9a plus 23. Notice that when you plug in a's, you get out more things with a's. And when you plug in numbers, you get out a number. So let's take a look at the next one, g of negative x. I'm plugging in something with an x, so I'm supposing that I'll have an answer with x's in it. Alright, so when I have g of x, going back to the original problem, g of x equals x squared plus 3x plus 5. That's the original function g of x, just with parentheses instead of x's. Now I'm going to replace all those x's with the whatever's inside the parentheses, in this case negative x. Okay, so when I take negative x squared, that means negative x times itself negative x, which turns out to be positive x squared. A positive 3 times a negative x is a negative 3x, and 5 doesn't have any change to it. So therefore g of negative x is equal to x squared minus 3x plus 5. On our last problem, g of a plus h. Notice there's two variables in here. No problem. That just means our answer is going to have two variables in it. Going back to the original problem, we have g of x equals x squared plus 3 times x plus 5. Every time I see an x, I'm going to put an open parentheses so that I can come back in and put a plus h in for every single time I see x. Now remember, when you have a binomial squared, you can't just distribute that squared. You have to write this out twice. Okay, so I have a times a, which is a squared. A times h, which is ah. H times a, which is ah. And h times h, which is h squared. Keep distributing on the next parentheses. 3 times a is 3a. 3 times h, which is 3h, plus 5. And now I have a squared. ah plus ah. Be careful here. A lot of students want to do some creative things here. This is just one copy of ah plus another copy of ah. And remember, when we are adding, we have to have like variables. Ah and ah are the same. And what we do is we add their coefficients. 1 plus 1 is 2. H squared doesn't have any like terms. 3a and 3h don't have any like terms, and 5 doesn't have any like terms. So g of a plus h is this very long polynomial, a squared plus 2ah plus h squared plus 3a plus 3h plus 5.